for x equals 3. This would be negative 3. Okay, whenever you substitute a number in for a variable, you should always put that number inside of parentheses. Solve number 1. Okay, I'm going to subtract m from both sides. So 5 is less than 8 plus m. Subtract 8, and negative 3 is less than m. Solve the second problem. I will add d to both sides. 1 is greater than 5d minus 7. Add 7. 8 is greater than 5d. Divide by 5. And d is less than 1 and 3/5, or 1.6. Okay, today we're going to use function notation to represent a function. To use function notation, if I have f of x equals negative 4x plus 7, and I want to evaluate that at x equals 2, the notation would state f at 2 equals negative 4, and now I plug the 2, or I substitute the 2 in for the x. So f at 2 equals negative 8 plus 7, which equals negative 1. Now you try the process for f at negative 2. And that should be negative 4 times negative 2 plus 7. F at negative 2 equals 8 plus 7, which equals 15. Now we will evaluate f of x at these points. First, for f at negative 4, when we substitute negative 4 in for x, we will get negative 8 minus 5, which equals negative 13. You try f at 0. So plug or substitute 0 in for x. And write your solution. Equal negative 5. Find f at 3. Two times 3 minus 5 will equal 6 minus 5, which is 1. And now find g at negative 4. we should have negative 4 minus 1. That turns to plus 4 minus 1, which equals 3. Now, in this case, we're finding when h of x equals negative 7. This is not substituting negative 7 in for x. Rather, this is substituting negative 7 in for the h of x, which would be right here. So now we're finding negative 7 equals 2/3 x minus 5. Now we have to solve for x. So we start by adding 5 to both sides. Negative 2 equals 2/3 x. Now we can multiply both sides by 3/2. Two-thirds times 3/2 cancels. Here our 2's will cancel, so negative 3 equals x. Equals 2x plus 3. Find when that function, g of x, equals 12. So you'll be taking when does 12 equal 2x plus 3. Solve for x. We should subtract 3 from both sides. So 9 equals 2x. Divide by 2, and x equals 4 and 1/2, or 4.5. Now we're going to make an input-output table for the following function, where f of x equals 2x plus 7. First, if I substitute negative 2 in for the x, we would have f of negative 2 equals 2 times negative 2 plus 5. So we receive the value of 1. Now if we substitute negative 1, we should get 3. 0 is 5. 1, you get 7. Now you evaluate the function at 2. And we should have received a value of 9. Now we can plot the ordered pairs onto a coordinate plane. So we have our point negative 2, 1, negative 1, 3, and so on. And now we can draw a line that will travel through those points. Now we are going to set up the chart and graph each one of these functions. So the first one, if we substitute negative 1 in for x in this place, we should have negative 5. 0 is negative 2. 1 is 1. And 2 evaluates to 4. Now after we have that, we can put those points onto a coordinate plane, and we have our line. Now you finish filling out the chart for number 7. And we should have 5, 4, 3, 2. There's our graph. And fill in the chart for number 8. Now to solve the chart for number 8, I'm going to choose to use -4, 0, 4, and 8. Since I have the fraction here of 3/4, -3/4, that will make our substituting easier. So when we substitute -4 in, our 4's cancel, negative times negative is positive, 3 minus 1 is 2. Substitute 0 in for x, and we will receive 1. Substitute in 4, the 4's will cancel, -3 minus 1 is -4. And substitute in our 8, and we have -6 minus 1, which is -7. And our graph will look like the following.